Imagine if a simple white powder sitting in your kitchen pantry right now held the potential to slow down the progression of chronic kidney disease and potentially delay the need for dialysis. It sounds like an old wives' tale or a dangerous internet myth. But what if I told you that major research hospitals and top nephrologists are actually prescribing this common baking ingredient to patients to save their kidneys from failure? Today, we are answering the burning question. Is baking soda a kidney-saving miracle, or is it a health myth that could land you in the hospital? Welcome back to the channel, where we bridge the gap between complex medical science and your daily wellness. We are dedicated to exploring the physiology of nutrition and body wellness, helping you make informed decisions about your health. Today, we are diving deep into the science of sodium bicarbonate, commonly known as baking soda. We will analyze the clinical studies, explain the biological mechanisms, and most importantly, discuss the safety protocols you need to know. Please remember, this video is for educational purposes only. I am not a doctor, and you should never change your medication, diet, or supplement routine without explicitly consulting your healthcare provider, especially when dealing with organ health. To understand why a box of baking soda is even part of the conversation regarding kidney health, we first need to understand the root problem it attempts to solve. The condition is called metabolic acidosis. Your kidneys are the master chemists of your body. While they are famous for filtering waste and balancing fluids, one of their most critical and often overlooked functions is maintaining the pH balance of your blood. The human body operates within a very tight pH window, slightly alkaline, between 7.35 and 7.45. If your blood becomes too acidic or too alkaline, your cells simply cannot function, and the consequences can be fatal. Every day, the food you eat, particularly animal proteins like meat, eggs, and dairy, produces acid as a byproduct of digestion. In a person with healthy kidneys, this is not a problem. The kidneys filter out this excess acid and excrete it through urine. They also regenerate bicarbonate, which acts as a buffer in the blood to neutralize any remaining acid. However, for those suffering from chronic kidney disease, or CKD, this system begins to break down. As kidney function declines, usually becoming noticeable in stage 3 and becoming critical in stages 4 and 5. The kidneys lose their ability to excrete the daily acid load. The result is that acid begins to accumulate in the bloodstream. This state of metabolic acidosis is devastating for the body. Think of it like a slow corrosion occurring inside your system. When the body realizes it is becoming too acidic, it goes into a state of emergency panic. To neutralize the dangerous acid, the body starts robbing Peter to pay Paul. It begins stripping calcium and magnesium from your bones because these minerals are alkaline and can buffer the acid. This leads to weak, brittle bones and an increased risk of fractures. Simultaneously, the body triggers muscle wasting, breaking down your muscle tissue to release glutamine, another buffer. Patients often feel exhausted, weak, and short of breath. But the most tragic part of this cycle is that the high acid levels stimulate the kidneys to work even harder, triggering inflammation and fibrosis that accelerates the death of the remaining kidney tissues. It is a vicious cycle. Kidney damage causes acid buildup, and acid buildup causes faster kidney damage. This is where the concept of baking soda enters the medical arena. Sodium bicarbonate is a base. It is the chemical opposite of an acid. The hypothesis proposed by scientists was simple yet profound. If the damaged kidneys can no longer produce enough natural bicarbonate to neutralize the dietary acid, can we simply ingest bicarbonate? If we can neutralize the acid orally, we might stop the bone loss, stop the muscle wasting, and halt the rapid progression of kidney failure. This is not just a theory. It is a practice backed by substantial evidence. One of the most landmark studies in this field was conducted at the Royal London Hospital and published in the Journal of the American Society of Nephrology. Researchers studied 134 patients with advanced chronic kidney disease and low bicarbonate levels. They divided them into two groups. One group received standard care, and the other received a daily oral dose of sodium bicarbonate tablets. The results were nothing short of remarkable. The patients taking the bicarbonate saw a dramatically slower decline in kidney. In fact, the rate of decline in the baking soda group was comparable to the normal, age-related decline seen in healthy people. Furthermore, the patients in the treatment group were significantly less likely to develop end-stage renal disease requiring dialysis during the study period. Since that study, further research has supported the idea that correcting metabolic acidosis is a key pillar of preserving kidney function. It suggests that by simply keeping the acid levels in check, we can preserve the intricate filters of the kidneys for years longer than previously thought possible. However, before you rush to the kitchen and start mixing a spoonful of baking soda into your water, we must pivot to the potential dangers. This is where the miracle narrative requires a heavy dose of reality and caution. The first and most obvious problem lies in the name, sodium bicarbonate. It contains bicarbonate, which is good for the kidneys, but it also contains sodium. A single teaspoon of baking soda contains roughly 1,200 milligrams of sodium. For context, a typical renal diet restricts. If you take a teaspoon of baking soda, you have consumed more than half of your daily allowance in seconds. For kidney patients, sodium is often the enemy. Damaged kidneys struggle to balance fluids. Excess sodium causes water retention, leading to edema, swelling in the legs, ankles, and even around the lungs. More critically, excess sodium raises blood pressure. Hypertension is the #2 cause of kidney failure, second only to diabetes. There is a very fine line to walk here. If you take baking soda to fix the acid problem but end up spiking your blood pressure to dangerous levels, you have simply traded one. Furthermore, there is the risk of overshooting the mark. While acidosis is bad, the opposite condition, metabolic alkalosis, is also dangerous. If you consume too much bicarbonate, your blood pH can rise too high. This can lead to symptoms like confusion, severe vomiting, muscle twitching, hand tremors, and heart arrhythmias. This is why self-dosing without blood work is incredibly risky. You cannot feel your pH level. The only way to know if you need bicarbonate is through a comprehensive metabolic panel blood test. Doctors typically look for a serum bicarbonate, or CO2, level below 22 millimoles per liter. If your levels are normal, taking extra baking soda offers no benefit and only adds unnecessary sodium and risk. Another practical side effect that many people overlook is the gastrointestinal distress. When baking soda hits the hydrochloric acid in your stomach, a chemical reaction occurs immediately. It produces carbon dioxide gas. This is the same reaction that makes a baking soda volcano erupt. In your stomach, this translates to severe bloating, belching, and abdominal pain. For some patients, this gas is so uncomfortable that they cannot tolerate the treatment. In a clinical setting, doctors might prescribe enteric-coated sodium bicarbonate tablets that are designed to dissolve in the intestines. Rather than the stomach to mitigate this issue, but raw powder from the box does not have this protection. It is also vital to distinguish between baking soda and baking powder. This is a common point of confusion that can have serious health consequences. Baking soda is 100% sodium bicarbonate. Baking powder, however, is a mix of baking soda and an acidifying agent, often containing aluminum. And, most dangerously for kidney patients, phosphates. Phosphorus is difficult for failing kidneys to filter and is highly toxic to the body. When it accumulates, causing severe itching and pulling calcium from bones. If you mistakenly consume baking powder thinking it is a health remedy, you are loading your body with dangerous additives that can accelerate disease progression. So, how do we navigate this? Is there a safer way to get the benefits of an alkaline body without the sodium risks of baking soda? The answer lies in your diet. This is often the first line of defense recommended by dietitians. Fruits and vegetables are naturally alkalizing. When your body metabolizes plants, the chemical process produces bicarbonate precursors. By significantly increasing your intake of kidney-friendly fruits and vegetables, you can naturally correct mild metabolic acidosis. This method provides the buffer your kidneys need, but it comes with fiber, vitamins, and antioxidants, rather than a massive load of pure sodium. This approach is generally safer for those in the earlier stages of CKD. However, for those in stage 4 or 5, the potassium content in fruits, and veggies must be monitored. Which brings us, in summary, the story of baking soda and kidneys is complex. Here are the 3 key takeaways you need to remember. First, understand the mechanism. Metabolic acidosis is a condition where acid builds up due to kidney failure, destroying muscle, bone, and remaining kidney tissue. Correcting this is essential for longevity. Second, weigh the risks. While baking soda effectively neutralizes acid, it brings a massive sodium load that can spike blood pressure and cause fluid retention. It is a double-edged sword that requires balance. Third, and most importantly, test, don't guess. You should never take baking soda for kidney health unless a blood test confirms your bicarbonate levels are low and your doctor prescribes the specific dosage. Ultimately, baking soda is neither a magic miracle cure that replaces standard medical care, nor is it a myth without scientific merit. It is a powerful, evidence-based tool in the nephrologist's toolkit, but it must be handled with precision. If you are concerned about your kidney function, ask your doctor specifically about your CO2 or bicarbonate levels at your next appointment. If you found this breakdown helpful, please hit that like button to help the algorithm share this vital health information with others fighting chronic kidney disease. Share this video with anyone you know who is managing their renal health. And don't forget to subscribe for more deep dives into the science of nutrition and body wellness. Take care of your kidneys, and they will take care of you.